today we have to see the next topic, that is the secant and tangent of the chapter number 3 of the geometry for the class 10. In the previous video, we have seen the introduction to the circle, its activity, and number of circle passing to the point 1, number of circle passing to the point 2, and number of circle passing to the point 3. So let's see secant and tangent. Now in the given figure, this is a figure 5. Here is what? A circle with the center A and the line L. Here is no point common in the both. Here circle and line are at the different places. In the figure second, here B is the center of the circle and M is a line. Where the point P is common in the circle and line. So the point P is known as point of contact. So line M is tangent to the circle with the center B. Here line M is a tangent to the circle with center as B. So here it has cleared that tangent is what? Where tangent and means circle and tangent, that is a line, has only one point of contact. That is, here the point of contact is simply point P. And next in the figure third, the circle with the center C and the line N has two common points, that is a point Q and R. Here point Q and R are intersecting points for the circle and the line N. So the line N is what? Line N is secant to the circle with the center C. Line N is a secant. Line N is a secant to the circle with center C. It has cleared that if the line intersects the circle into two distinct points, so it forms a secant. Here Q and R are the points of intersecting to the circle and the line N. So here it has cleared that tangent means what? Only having one point of contact for the line and circle. Now we have to see the activity which is given on the page number 50 of your geometry textbook. So what does the activity says? Here one figure is given. It has said that draw sufficient large circle with the center O. The sufficient large circle is given with the center O. Draw radius OP. Draw line AB which is perpendicular to the OB. It intersects the circle at the points A and B. Imagine the line slides toward the point B. The same number of lines are sliding toward the point P, such that all the time it remains parallel to its original position. Obviously, while the line slides, the points A and B approaches each other along the circle. Whenever we draw a parallel line to the original drawn line, which intersecting to the circle at the point A and B, they should be parallel, and that line is what? They are again intersecting circle into 2 points. At the end, they get merged in the point P. Here it is given that at the end they are getting merged to the point P. But the angle between the radius OP and the line AB will remain the right angle. Means angle is what? They are perpendicular, so it remains the same, that is the right angle. At this stage, the line AB becomes a tangent of the circle. At the last, it becomes tangent to the circle. That is, the line intersects the circle at only one point, that is the point P. So it remains the tangent. So it is clear that the tangent at any point of the circle is perpendicular to the radius at any point. This property is known as tangent theorem. Now we have to see that is tangent theorem. Now we have to recall the statement, that is a tangent at any point of a circle is perpendicular to the radius at the point of contact. Means tangent at any point of the circle. Here we have taken a tangent here to the circle, which is the point of contact is what? A, and O is the center and OA is the radius. So the proof of this theorem is what? The proof of this statement is given by indirect proof. Indirect proof, or simply we can say that proof by contradiction. In the class 9, that is in the previous class, the first chapter of your geometry, we have studied that there are two types of proof, direct proof and indirect proof. So this theorem proof we have to prove with the help of the indirect proof. Indirect proof is what? Simply the part to prove which we have to consider as a false. So here the proof will be, first of all we have drawn one figure. Okay, here is what? Circle with the center O. OA is the radius, here is the tangent, and the point of contact of the tangent and the circle is A. This is given. What we have to prove? That the line L is perpendicular to the radius OA as per the theorem statement. This we have to prove. But this is what? Proved by indirection. That is indirect proof. So we have to assume that line L is not perpendicular to the segment OA. Means what? Line L is not perpendicular to the segment OA. What we have to prove? That OA is perpendicular to the line L is. Now to prove is what? Line L is perpendicular to the radius OA. But this theorem proof we have to prove with the help of indirect proof. So what we have assumed that? Assume that line L is not perpendicular to the segment OA. Means what? L is not perpendicular to the segment OA. So suppose the segment OB. So we have suppose that segment OB. That is the figure number second. Suppose the segment OB is drawn perpendicular to the line L. Suppose we have drawn another segment OB which is perpendicular to the line L. Of course, B is not same as A. Here OA is what? Radius. So OB is what? This is not same as the OB. Now take a point C on the line such that now the same line L, on the same line L we have to take the point C such that A, B, C are what? Collinear. That is, they are on the same line. Such that, and the distance AB equal to BC. Now in triangle OBC and OBA, that is OBC and OBA, segment BC is congruent to the segment BA. That is, reason is what? With the help of the construction. Now we have done. Next is what? Angle OBC is congruent to angle OBA, that is 90 degree each, because OB is perpendicular to the line here. So it forms a right angle, that is 90 degree. Segment OB equal to OB, common side of the two triangles. Therefore, by angle side test, we can prove that the two triangles are congruent. If the two triangles are congruent, then corresponding parts of the congruent triangle are also congruent. Therefore, OC equal to OA. And what? OC equal to OA means what? Here OA is the radius. Therefore, the segment OA is the radius. So segment OC must also be the radius. And C lies on the circle. If OC is the radius, then C lies on the circle. That means line L intersects the circle into two distinct points. If the line L intersects the circle into two distinct points, then what it forms? It forms a secant. That is A and C. But line L is what? Tangent. It forms a secant. But what we have given that it is a tangent. It intersects the circle in only one and only one point. If it is a tangent, then it should intersect the circle at only one and only one point. Therefore, our assumption that what we have assumed that line L is not perpendicular to the segment OA is what? Wrong. Therefore, line L is perpendicular to the segment OA. In this way, we have proved the tangent theorem with the help of the contradiction, or simply with the help of the indirect.